In this video, I'm going to be going over exactly how to figure out what type of compound something is just based off of its chemical formula. So on the periodic table, you might have seen this before, that there is a staircase line that just kind of goes like over and down, over and down, over and down. That staircase line separates out the metals from the nonmetals. The nonmetals I'm highlighting first, so that is everything that is in green. The nonmetals in general have more valence electrons and selenium. The metals are going to be all the ones that are being highlighted right now. There's many more metals than there are nonmetals, including these two blocks at the bottom of the periodic table. Okay. Everything that's not highlighted right now currently is technically called a metalloid. Actually, I would consider boron a part of that too, so I'm going to erase that. Metalloids are kind of in between metals and nonmetals. Most of the time we treat them like they're nonmetals in cases of bonding, but just so you know, it's not technically considered a metal. So if you see it colored differently on a periodic table, that is why. Another thing I want to point out is hydrogen. Hydrogen is an exception to the staircase rule. It is the only nonmetal that is on the left side of the staircase. And the only reason we have it over there is because hydrogen has one valence electron, similar to all of the alkali metals below it. So it's just to categorize hydrogen with all of those. It forms a lot of similar compounds to the alkali metals, so keeping them together actually does make logical sense. Okay. So how do you figure out if something is ionic or covalent or one of the other types of compounds just from the chemical formula? Well, you have to sort of know what types of elements make up the different compounds. So starting with the basic ones, ionic, covalent, and metallic. Ionic compounds are made up of a metal and one or more nonmetals. These can have one nonmetal, they can also have more than one. So an example of an ionic compound might be like magnesium bromide, because when you look at the periodic table, magnesium is here, it is a metal. Bromine is over here, it is a nonmetal. So you have one of each that is a ionic compound. You can have more than one though. So if you had like sodium nitrate, NaNO3, this has sodium, nitrogen, and oxygen. Sodium is over here, it is a metal. Nitrogen and oxygen are both nonmetals, so it's still considered an ionic compound. You are allowed to have more than one nonmetal, and actually that's pretty common. A covalent compound only has nonmetals, so this would be something like carbon dioxide. When you look at where carbon and oxygen are on the periodic table, carbon is here, oxygen is here. Those are both nonmetals, so that makes that a covalent compound. Another example would be water. Water is a covalent compound because it has hydrogen and it has oxygen, so both nonmetals. Metallic compounds we are not going to talk about a whole lot, but really this is just going to be anything that only is made up of metals. Typically, we're just talking about alloys and just metal elements here. So this could be like iron. Iron has metallic bonds, but this could also be something like brass, which is a copper and zinc alloy. It's mostly copper, but it has a little bit of zinc dissolved into it. So that would be metallic as well. There's not a whole lot to say about metallic bonds. So this really isn't going to be the focus of the class. The other types of compounds, there's a lot more to talk about. So that's generally where we're going to focus. All right, the last two are acids and hydrates. And these are just like slightly more complicated examples of ionic and covalent compounds. So an acid needs to have two things in its formula. It needs to start with hydrogen. Hydrogen is always going to be the first element. And it also has to be aqueous. These are generally going to look like covalent compounds, but they're going to start with hydrogen and be aqueous. So an example of an acid would be like HCl, AQ. So you have two things in the formula that you're looking for, hydrogen and aqueous. You need both of those things. If you only have one of them, that is not an acid. It needs to have both. So if I were to write like NaCl aqueous, that would not be an acid because it does not start with hydrogen. It needs to have both of those things to be considered an acid. Another example would be like H2SO4, that's sulfuric acid. So it starts with hydrogen and it's aqueous. You are allowed to have more than one hydrogen. In an acid, you will generally have as many hydrogens as you need to balance the charge of the negative part. So it kind of depends on what the hydrogen is paired with, how many hydrogens you're going to need to do that. Hydrogen, remember, has a +1 charge. All right, hydrates. A hydrate is an ionic compound that has absorbed water. And you can definitely spot these from a mile away from their chemical formulas because they look something like this. You will have the ionic compound first, a dot, and then a number of water molecules. And that's really just telling you how much water the substance has absorbed. So in this example, there's 5 times as much water as there is ionic compound. But these are very easy to spot because they have a very long, very complicated formula, and they are the only thing that looks like this. To remember that this is a hydrate, just look at the last part. This is water. Remember, water is hydration. So if it has water at the end of its formula like this with the multiplication dot, that is going to be a hydrate, right? So those are pretty easy to spot. But those are going to be slightly more precise examples of ionic and covalent compounds, but that do have slightly different naming conventions that we will learn this unit. All right, that's all. Bye.